Hi, everybody. So, we're going to be working on, and this is video attempt number 3, so hopefully it goes better than the first two. We're going to work on combination, which is when we're just trying to get the count of the groups of the objects, and permutation, which is the actual count of the groups, and then the orders that we can assign to each one, or the orders that can occur from each one of the groups of objects. So I'm going to talk about combination as groups, and I'm going to talk about permutation as orderings. And first, and I have some other videos posted there from an old text, and so there's other stuff kind of filtered in there as well. But I'm going to try and sort of bring all of the information together. And let's start off with, and let me begin by saying, when we're talking about orderings, this thing factorial comes into play. And the symbol for factorial is the exclamation point. And so if you have 4 factorial, that works out to be 4 multiplied by 3. And I'll use the asterisk to indicate multiplication. So 4 multiplied by 3 multiplied by 2 multiplied by 1, which is 24. Now, what we're going to start to say is that there are 24 orderings or permutations of 4 objects. So we can think of the numbers as just objects, and so the first object would be 1, 2, 3, then 4, then 1, 2, 4, 3, then 1, 3, 2, 4, then 1, 3, 4, 2, and then 1, 4, 2, 3, and then 1, 4, 3, 2. Well, that's the first 6 of them. Those are the first 6 orderings of those 4 objects. And now we're going to pick an object 2, and then we're going to go 1, 3, 4, and then we'll have 2, and we'll have 3, 1, 4. We'll have 2, and we'll have 4, 1, 3, and then we'll have 2 and 1, 4, 3, and then we'll have 2, and then so 3, 1 and 3, 1 and 4. Now we've got to do 4 and 3, it looks like. So 2, so 4, 3, 1, and then 2, 3, 4, 1. And that's the 6th there. And now we're going to put the value 3 first, or the third object first, and then 1, 2, 4, and then 3, 2, 1, 4, and then 3 will have 2, 4, 1, and then 3 will have 4, 2, 1, and then 3 will have, so we did 1, 2, we did 2, 4, we need to do, hold on, let me get there real quick, or real slow, depending. So I need to do 1, 4, and then 2, and then 3, 4, 1, 2, and then finally with 4. So 1, 2, 3, 4, 2, 1, 3, 4, 3, 1, 2, 4, 1, 3, 2, and then 4, 2, 3, 1, and then 4, 3, 2, 1. I think I've got them all listed, and I might have duplicated by accident, but hopefully I didn't. So there are 24 different orderings of 4 objects. There are 4 factorial orderings of 4 objects. Now, let's do this. Let's do 3 factorial. And so 3 factorial, again, we would just think about it as 3 times 2 times 1, which would be equal to 6. So there are 6 different orderings that could occur. And they would go 1, 2, 3, then 1, 3, 2, and then 2, 1, 3, and then 2, 3, 1, and then 3, 1, 2, and then 3, 2, 1, and then 2 factorial is equal to 2 multiplied by 1, which is 2. And if you have two objects, it's either 1, typo, which is 2. It's either 1 and then 2, or it's 2 then 1. So those are our two orderings that can occur. And then 1 factorial is just 1, because there's just one way to order 1. Now, when we're dealing with factorial, if you watch some of the other videos, you'll find out that 0 factorial works out to be exactly the same as 1 factorial, which is equal to 1. Now, the explanation is in the other ones, other videos, but I'll do a brief one here. So, n factorial is equal to n multiplied by n minus 1 factorial. And so, what's going on here is you can choose an n. N is just some natural number, like a 1, a 2, a 3, a 4, a 5, that kind of thing. And what happens is if we say n is 5, for instance, so 5 factorial, 5 factorial, well, that's going to be the same thing as if I took 5 and I multiplied it by, now in here would be 5 minus 1. Well, 5 minus 1 is 4, so 5 multiplied by 4 factorial, 4 factorial, those two things are equal. And so the argument quickly goes this way. Well, what if n's 1? So 1 factorial is going to be equal to 1 multiplied by, 1 minus 1 factorial. Well, 1 minus 1 is going to be 0. So what this is really saying is that we have 0 factorial on that side. Well, 1 times anything is itself, or is that object. And so this really becomes that 1 is equal to 0 factorial, and we know 1 factorial to be 1. And so it's a brief proof or a quick explanation as to why 0 factorial is 1. It actually comes from a thing called the integration of the gamma function, and then the gamma function actually shows that is the result. But that's a brief description as to, or a soft description as to why that's actually the case. Now, let me point out again that this statement here is that there are 4 factorial orderings of 4 objects. So, dropped a G. So if you have 4 objects, there are 4 factorial orderings of them. If you have 3 objects, there are 3 factorial orderings of them. If you have 2 objects, 2 factorial orderings, and so forth. And that's going to come into play when we start talking about the differences between these two formulas. So let's begin, or not really begin, but let's pick up with the following. I'm going to delete that. And I'm going to say, well, suppose that we have 6 objects, but we only want to permute 4 of them at a time. Well, what's going to happen is we're looking at having 6 spaces. So 1 space, 2 space, 3, 4, and that's it. But I'm going to write 5 and I'm going to put 6 down. I'm going to draw this line like this. So the stuff that we want, so what's going to happen is that we're going to kind of think about it this way. If I have 6 objects in total, and suppose I have these 6 spaces, well, there are 6 possibilities for the first spot. And once one is chosen, then there are 5 possibilities for that next spot. And once one is chosen, then there are 4 possibilities. And then there are 3 possibilities. And then there are 2 possibilities and 1 if we're dealing with all 6 objects. Now, here's the thing. We only want the first 4, and we're trying to deal with some kind of mathematical operation that will drop these off or cut these 2 out. So we're only talking about the first 4 spots, because we're trying to take 6 objects and permute them 4 at a time. So what we need is these 2 spots here to cancel the 2 and the 1 out. So we need a 2 and a 1 to come from the fact that we have 6 objects in total, and we have 4 spots that we're working with, and we're trying to generate the 2 and the 1 to get canceled off, or create a way to cancel off this 2 and this 1. Well, it works out that if we do 6 minus 4 factorial, we end up with 2 and 1 being the result in the denominator. So what I'm going to do is save and close. I'm going to delete that, and I'm going to write it this way. So suppose, again, we had the 6 objects, whatever those 6 objects are, and we're going to permute 4 of them at a time. Well, 6 permute 4 is going to have my equal sign. It's not, what in the world? That is supposed to be an equal sign. We're just going to pretend that that's an equal sign. Okay. I don't know why it's doing that. So what we do is we take the n, the first number, and we're going to have that in the numerator, and that's going to be 6 factorial. And then what we're going to do to generate the 2 factorial in the denominator is we're going to go 6 minus the 4. And so these 2 values, the 6 and the 4, we subtract, and that will get us 2 factorial, and that will leave us with the 6 times the 5 times the 4 times the 3. And so the permutation formula is NPR, which is equal to n factorial divided by n minus r factorial. Now, sometimes you'll see some other variations of this notation. So I'm going to leave that up for right now, and I'll hit return twice, and I'll show you what I mean. So sometimes you'll see the NPR notation. Sometimes you'll see the P with the N like up here and then the R there. And sometimes you'll see a P with a paren and then the N and then the comma and then the R. And I've seen 1 or 2 other versions of this before, but generally these are the 3 that are the most common. Now, there is a relationship between the permutation formula and the combination formula, and it goes back to what we were just talking about with the 4 factorial or of 4 objects, that kind of thing. And what happens is we take the permutation formula, and we'll go back to that 6 factorial, and then we'll divide that by the 6 minus, 6 minus 4 factorial. And what we do is we recognize that we only want the count of the number of groups. The orderings don't matter, but each group that we're working with, we need. And so what we end up doing is we divide out, if there's 4 objects, we divide out the 4 factorial orderings of those 4 objects, just giving us that group that exists. And so this is actually the formula if you're doing if you're doing 6 choose or combination 4. Now, there's some other notation for this combination formula. So sometimes you'll see it with the C, and you'll have the 4 here. I'm sorry, not the 4 there. You'd have the 6 here, and then you'd have the 4 down here. Sometimes you see it with the C, and then you have the parentheses, and then you'd have the 6 and the comma, and then the 4. And sometimes you would see the, oops, you wouldn't see the C at all, forgive me, and you'd see these parentheses, and then you'd see the 6 and then the 4. Oops. There. Okay. And if you see it in this notation, it's referred to as the binomial coefficient, but it's still the exact same formula. And so if we're going to do the formula, which I will, we'll write that out. Insert, drawing, new. So it is squiggle line, n, choose, or combination. It gets stated as choose a lot of times. Come on, equals. NCR is equal to n factorial divided by n minus r factorial. And then remember, we've got to divide out the r factorial orderings of r objects. And so this is the formula to get you groups. And the one up here is the formula to get you the groups as well as the count of all the orderings that can occur. All right, so that's the difference between the two. Now let's do one or two examples. I'm going to try and get my cursor to go here. Good. And we're going to say, what is the probability of getting the following? Now, I'm going to do an example this way. Suppose there's 10 lakes. There are 10 lakes. 6 are clean and 4 are contaminated with some dioxin. Okay. Now, we want to do some kind of sampling. We don't have the resources to be able to sample all 10, just pretend. So we want to know the probability of, when we draw a sample of 4 lakes, the probability of getting 2 that are contaminated and 2 that are clean in our random sample. So I really should have what is the probability. Okay, so we're going to hop back onto the drawing tab. We'll go here. I'm going to argue that order doesn't matter. You could make an argument, I suppose. And if you did, then you'd be making an argument with permutation. But I'm going to argue order doesn't matter. We're just looking for the groups that could occur. And so the first thing we need is the how many total groups exist. Well, the different groupings of size 4. We have 10 total lakes, and we're trying to pull out 4 of them. And so it's 10 choose 4 in the denominator. Now in the numerator, we have two things going on. We have contaminated, and we have clean. Now let me just go back here. 6 of the lakes are clean, and 4 of them are contaminated. So we have to think about the numerator as if it has 2 groups. So just let me go back here for a second. 10 choose 4, that's our denominator. Well, there are 6 clean lakes, and out of the 6 clean, we're trying to get 2 of them multiplied by, and there are 4 contaminated lakes, and out of those, we've got 2 of them. Well, you can write that up and do all the factorial work. You can also type this into your handy dandy graphing calculator. Let me do this. So to get 10, choose 4. Let me get that to stop doing that. So you want to get each one of the values. So you would hit the math key. You would arrow down to PRB. Depending on how your calculator looks, so most of them would allow you to arrow down, and then you'd see NCR, and the more modern ones will just have these like square, it'll look like this. So we've got scribble. You'd have this little square, and then you'll have a C, and then you'll have another little square, and you'd put the 6 here and the 2 there for 6, choose 2. You'd put the 10 here and the 4 here for the 10, choose 4. But that doesn't always appear that way. Sometimes, if you have an older calculator, all you'll see is this visual. Forgive me. And when you see this visual, you get this square, and then you have this N, and then you have this C, and then this R, and then this other square. And if you have this format, what you have to do is you start off with typing the number 10 or the number 6. You end up typing this one first, and then you hit the math, the PRB, and then the NCR. And what your screen will show you at that time is the following. You're going to have, suppose it was the 10, you type the 10, and then it'll show you 10 NCR, and then it'll have a blank box waiting for the 4 to be typed in, and then you hit enter, and it'll do the computation work for you. There are times when you can freeze your calculator, or it won't produce an answer because you have too large of values in here. And if that's the case, it's actually better on your main screen to type all of it in at once, and then the computer will deal with the complexity as best as it can. So this shouldn't freeze your calculator, but if you had like 16, choose 2, and 14, choose 2, and then this would be 24, choose 4, it might freeze it up if you do it individually. So you are better off if you can type it all at once. If you're doing that, what you're going to need to do is you're going to need to throw in parenthesis and parenthesis to keep that in the top, and then the division bar, and then you want parenthesis and parenthesis if you've got anything complicated in the denominator. Okay? All right. So hopefully that makes a little bit of sense. Let's do another example. Suppose you want the probability of 2 hearts, and we're just dealing with regular cards. 2 hearts and 2, and we'll say clubs. Okay? And we're choosing 4 cards out of a standard deck of cards. So we'll do the following. So the denominator, well, there's 52 cards in total, and you are choosing 4 of them. Now there are 2 groups. There's actually 4 groups we're talking about. So you have clubs, you have hearts, you have spades, and you have diamonds. But we're only focused on 2 of them. So out of the 13 hearts, you are choosing 2, and out of the 13 spades, you are choosing 2. I'm sorry, clubs, you are choosing 2. And really, what's happening is out of the 13 diamonds, you're choosing none, and 13 choose 0 or 14 choose 0 or 17 choose 0 is 1. So you don't need to write that in there. Those can be just ignored because you're just getting the value 1. Okay? All right. So hopefully that makes sense. And I want to edit this. So if I can get rid of, I'll just delete that off. So if we change this to 2 reds and 2 blacks, we would do the following. So again, you would still in the denominator have 52 choose 4, but out of the 26 red cards, you're choosing 2, and then out of the 26 black cards, you are choosing 2. And then again, you put that into the graphing calculator. So hopefully that makes sense, and you can see the connection between the permutation and combination. All right, that one went a little better than the other ones did. Have a good one.